Part 1 of the video about integration of exponential functions. We solved these 3 questions. Just try to watch the first video that I have uploaded. Now we're going to continue with this one. Again, what we're trying to use is this one, e to the u du, and that's equal to e to the u plus k. However, in this next part of this video, I'm going to discuss something more complicated. So for example, the integral of e to the sine x dx. Right? Now, as you can see, this one, first let's try to analyze, can we use this formula for us to be able to solve this one? Again, upon checking our u there, okay, I think let's just use substitution. So let u is equal to your sine x, and then the derivative of u is equal to cosine x dx. So when you do the substitution, okay, when you do the substitution here, this one will be the integral of e to the u, and the dx. From here, the dx is equal to 1 over cosine x du. Okay, so let's try to plug it in. So du, then 1 over cosine x. I will just, can I erase this one here? So dx there. So this is going to be 1 over cosine x, which, as you can see, it becomes more complicated. And you notice here that this is u and that is u, just the same variable. But in here, after the substitution, the original question becomes 2 different variables. So therefore, this kind of question cannot be answered by this formula. Okay? However, let me just rewrite that one in such a way that it will be answerable using that formula. I will just try to change it to this question. Look, so now the question now is this: find the integral of cosine x e to the sine x dx. Okay, so again, our u is equal to sine x, and the derivative of your u, the derivative of that u with respect to x, is cosine x dx. And please take a look that in the question, this cosine x is there, this dx is there. Okay, so by substitution, let's not do the substitution. Let's copy that integral. Okay, e to the sine x, e to the sine x, but your sine x is your u. But take note that the cosine x dx, the one in the blue, is actually du. Okay, so therefore, look, in this one, in this question here, the complicated problem like this, after you do the substitution, becomes a simple question like this. So it means that the substitution should be something that will make the question more simple. Okay? So that is now equal to e to the u plus k, or e to the u, which is sine x, plus k. This is now the final answer. Now, I don't know if you noticed that, but I just want you to look into the way how I created the question. This is sine x, and the derivative is there, cosine x. Okay, so I'm pretty quite sure this one is solvable. All right, so let's try to have another example. And I want you to think that way. Let's say e to the integral of x squared dx. So basically, in your head, think of that x squared. This one. Think of that. And the derivative of that. Think in your head the derivative is equal to 2x. But is that 2x in here? In the question? It's not. So therefore this one cannot be solved. Okay? Cannot be solved. So let me just rewrite the question. What shall we do with this one to make it solvable? Well, either you can put an x here. Okay? So that's the way. Again, the reason why I would like you to think that way, it's because if you have the examination, if we're looking at the question, you should actually know what techniques of integration are you going to use. And for you to be able to know the techniques, then you should be able to understand the anatomy of the question. Okay? So again, in here, our u, let me just do it step by step, is equal to x squared. The derivative of u is 2x dx. Okay? And now, look at now the magic. The x dx is here. Can you see? The x dx is there. So we want that expression for x dx. And that x dx is actually 1/2 of your du. Now let's do the substitution. You copy that integral symbol, you copy the e to the x squared. That is e, but your x squared is u, e to the u. And the x dx, this one, is equal to 1/2 du. du, you put the 1/2 outside. So therefore now you have 1/2 e to the u plus k, or 1/2 e to the u, your u is x squared, plus k. Alright? Now, again, before I end this video, the one that I'm trying to tell you is that always check the question and the derivative. Okay? So, for example, in here, you have the sine x as for u. Try to check if the derivative of that one is included in the question. If it is not included, then most likely this approach cannot be used. For example, here, that is sine x, but it's not, the derivative of that is not included in the remaining question. So therefore, it cannot be solved that way or this way. Alright? So that's all for this video. I'm gonna be giving more integration problem as we go along. Thank you.